Hi guys, welcome back to our mathematics tutorial. Again, my name is Peter C. Junior, your math tutor, and this is implicit differentiation and that of natural logarithm. So it's actually under implicit differentiation, but we will also use natural logarithm to assist us in solving this problem or each of these problems that we have. So the first one says y raised to the power x, x raised to the power y equals to 1. So what if you try, let me put something down here. What if you try y raised to the power y plus x raised to the power x or equals to 1? So you can also try that as well. Now let's look at this. Now this is not the power rule wherein you bring this power down and you subtract 1 from this power. No, it's not. It's not the power rule. We told you the power rule you can only use the power rule when you have numbers. These must be numbers, right? Now, since these are functions, you cannot use the power rule. So what we can do is that we can bring in natural logarithm, but we cannot take the ln on both sides because the fact that we notice that we have two terms here and we have one term here. So if we take the ln on both sides, the ln on this side will not allow us to ensure that these powers drop. No. So we can allow each of these terms to just be a function. So we can say let r equals to y raised to the power x, and we deal with them separately. So we take the ln of r, the ln of y raised to the power x. So ln of r equals to x. We bring this x down, ln of y. So differentiate both sides. Now we have 1 all over r times the derivative of r, which is r prime. We hold x and differentiate ln of y is just 1 over y times the derivative of y, which is now y prime, plus we hold ln of y and differentiate x, just give us 1. So now we have r prime. Now this r will be multiplied by this expression. So it's r times, so this is x y prime all over y plus ln of y. What do you observe? This r now is, r is just equal to y raised to the power x, x y prime all over y plus ln of y. Now we've gotten the first one. We've gotten the derivative for this expression. Now we can find the derivative of this expression as well. So we can say let p equals to x raised to the power y. That is, if we take the ln of p on both sides, take the ln of p of this equation. Let's say take the ln of p and take the ln of x raised to the power y. So we're going to have ln of p is equals to y ln of x. Bring this power down, right? Differentiate 1 over p times the derivative of p, which is just p prime, because p is the name of this new function. So we must dash p prime. We use the product rule right here. We hold y and differentiate ln of x. It gives us 1 over x times, let's say plus, we hold ln of x and we differentiate y, it just gives us y prime. So this is p prime. Now this p must be multiplied by this expression. So we have p times, this is now y over x plus y prime ln of x. And then this p now is just equal to x raised to the power y, y over x plus y prime ln of x. Now what we need to do is to just find our final solution by putting it in and solving for y prime. So we just need to, so this expression, the derivative of this y to the power x is just equal to y to the power x times x y prime all over y plus the ln of y. And then the derivative of this one is x to the power y times y over x plus y to the power, let's say y prime ln of x. So our objective now is to, and all equal to the derivative of 1 is just equal to 0. So we need to now solve for y prime, and so that we'll be able to find our general solution. So this time, what do we have? We have y raised to the power x. So x comes outside, and then this y that is down here can go within the numerator. The power will change to negative, and then you have y prime plus y to the power x times this is y to the power x times ln of y, plus the same thing with this side, x to the power y. This x can go in the numerator. It becomes x to the power minus 1 times y. Multiply this by the second one. You have x to the power y prime ln of x, or equals to 0. So this term has y prime. This term also has y prime. So we group them. We have x y prime. Let's say x raised to the power y raised to the power x minus 1. And in this term, we have x raised to the power y ln of x. And then this y prime is outside because this term it has y prime, this term also has y prime. So we just factor it out. All equals negative. So each of these go across. You have y to the power x ln of y minus x to the power y minus 1 y. So if we divide this side and this side by this expression, we're just going to have y prime to be equals. Now we can factor out this negative. So we would just have y to the power x ln of y plus x raised to the power y minus 1 times y divided by this expression right here. So we're going to have y raised to the power x minus 1 plus x raised to the power y ln of x. So we call this our answer. We don't need to be struggling on what to do next. So we can call this our final answer. And let's move to the next one. So for question 17, we have to use ln. I think this is equal to, let me see that problem. So 17, ln is already there, right? So the only thing we need to do is to bring in the property of logarithm. So the first thing we know is that the power of this function will have to come behind the logarithm. So we can rewrite it as 1 over 6a raised to the power 3 ln of x cubed minus a cubed all over x cubed plus a cubed. So that's the first one, right? The next one is for us to also expand this one. We know that the ln of a over b is equals to the ln of a minus the ln of b. So this is a and this is b. So we have y equals to 1 over 6a cubed, the ln of x cubed minus a cubed, minus, now just do it like this, ln of x cubed plus a cubed. Now let's differentiate that after we've done that. So y prime now equals to 1 over 6a cubed. Now the derivative is 1 over x cubed minus a cubed, and then times the derivative of what is inside, which is just 3x. Subtract 1 from the power is 2. The derivative of a cubed is 0 because a is a constant in this problem. Minus 1 over x cubed plus a cubed. And the derivative of x cubed is just 3x squared. So y prime now is just equal to. Now 3x squared, we can bring it outside. It becomes 3x squared all over 6a cubed. And then down here now is just x cubed minus a cubed times x cubed plus a cubed. So x cubed minus a cubed goes into this. It cancels. You're left with this one. Remember, this is already outside. This is already outside, right? So you just have 1 here. We have 1 here as well. These two are not there any longer. So this now becomes x cubed plus a cubed. Because if this goes into this, it cancels. You're left with this. So it's this times this one. Minus this goes into this cancel. You're left with this one. So it's negative times this is negative x cubed. Negative times negative is positive a cubed. So x cubed and x cubed go out. We are left with so y prime now is just equal to 3 here 1 times 3 into this 2 times. So it's x squared over 2a squared a cubed. And then what next? We have 1a cubed and 1a cubed. So this gives us 2a cubed divided by a cubed minus a cubed. Let's say x cubed minus a cubed and s cubed plus a cubed. So this cancel this one. So finally we have y prime to be s squared all over s cubed minus a cubed times x cubed plus a cubed. So let's do the last problem. Last problem says y equals to the ln again. Because the ln is already there, so we just have to bring this power down. So it becomes y now equals to 2 the root of 2 ln of 1 plus the root of 2x all over 1 minus the root of 2x. It's just similar to what we just were doing. So what we need to do now, we need to apply this property. So we have y equals to 1 over 2 the root of 2 ln of 1 plus the root of 2x minus the ln of 1 minus the root of 2x. So we differentiate. We have y prime to be 1 over 2 the root of 2. So this first one is just 1 all over 1 plus the root of 2x times the derivative of the root of 2x, because the derivative of 1 is 0. So the derivative of the root of 2x, derivative of x is just 1. So because of this coefficient, now you just have the root of 2 minus 1 all over 1 minus the root of 2x. And then what do we have? So the derivative of the root of 2x is just equal to minus the root of 2. So minus and this minus, it gives us positive. So now this root of 2, we can factor it out. We have the root of 2 all over 2 the root of 2. So we can find our LCD between these two is just 1 plus the root of 2x times 1 minus the root of 2x. So this goes into this and this cancel. You'll be left with this. So it's this times this 1. Remember, the root of 2 and this root of 2 already outside. So it's 1 minus the root of 2x plus this goes into this and this cancel. You're left with this one. So it's 1 plus the root of 2x. So the root of 2x and the root of 2x can cancel. We're left with this one and this one cancel as well. Y prime to be 1 plus 1 is 2. So it's 1 over 2, 2 all over 1 plus the root of 2x, and then 1 minus the root of 2x. So this 2 and this 2 can also cancel. And finally, we'll just be left with y prime to be equal to 1 all over 1 plus the root of 2x times 1 minus the root of 2x. So if we like, we can multiply these two because these are conjugate of each other. So y prime will just be 1 all over 1 times 1 is 1. And then 1 times root of 2x will give you minus root of 2x. Root of 2x times 1 will give you plus root of 2x. Root of 2x times root of 2x will give you minus 2x squared. So you don't necessarily have to even say this time this time this, because the middle term will always cancel as long it is conjugate of each other. That is, the expressions are the same with different signs between them. So this and this cancel. So you can just say 1 times 1 and the root of 2x times the root of 2x. That's all. So finally now our answer would just be, our answer would just be 1 all over 1 minus 2x squared. So this is our final answer. So thanks all so much for watching, and see you in our next lecture. Thank you.